Let us see how to get the help for the floating point numbers using the help and directory methods. Let us run this cell by placing float inside the help function. Here we can see detailed explanation on floats with the help of the help function. So by using the float constructor, we can convert a string or a number to a floating point number if possible. And we can see the methods defined for the floats like absolute, add, boolean, seal, and so on. Less than or equal to, less than, modulus division, multiplication, or operation. We can use hexa function or method to get hexadecimal representation of a floating point number. And we can use the conjugate method to get the complex conjugate of any floating point value. We can check whether the provided number is integer or not using isInteger method. It returns true if the floating point value is an integer. Means by unknowingly, if we use the integer as floating point value, then we can check with the isInteger method. Next, we have some class methods defined for the floating point value, and also the static methods and data descriptors for the floating point values. We can represent complex number using the floating point numbers. So we can use the floating point number to represent a real part and floating point value to represent the imaginary part of the complex number. Let us see these attributes and methods using the directory method. Here we can see the different attributes and methods available for the floating point values. Let us see how to create the floating point values using the float constructor. Here I am using 23 to create the floating point value using the float constructor. So we got 23.0. So 0 has been placed after the decimal point. If we do not have a decimal point after the decimal point, let us use the string digital value to create the decimal part and also the floating point value. 23.4. After decimal, we have used 4 to represent this digit as the floating point value. So we got 23.4. If you look at the signature of the floating point constructor, we can convert a string or a number to a floating point number. So we can use a string which can be able to convert either to an integer value or to a floating point value. So we have used both number as well as string to create the floating point values. All the arithmetic operations are similar to like integer values, which exactly apply for the floating point values. So we are omitting that part here. So please consider this as an exercise. Suppose if we have a complex number, as I told you earlier, we can use floating point value to represent the real part as well as the floating point to represent the imaginary part. Here I am using 3.4 to represent the real part and 7.8 to represent the imaginary part by concatenating j. J is used to represent the complex number in Python. And we know that we can use the imaginary and real methods, built-in methods, to extract the imaginary and real part of the complex number. Imaginary part is 7.8 and the real part is 3.4. Next, let us see the seal method applied on the floating point value. 3.456. Let us apply the seal method on this and see what is the result, and also with the round method. Seal method will convert the fractional part to a next highest integer value and convert the whole floating point value to n next highest integer value, whereas round method will convert the fractional part to n next lowest integer value and the whole floating point value to n next lowest integer value. So 3.456 has been converted to the next highest integer value using the seal method. 4. And 3.456 has been converted to next lowest integer value, that is 3 only, using the round method. So let us see the list of attributes and methods and total number of attributes and methods. 59, which are lesser than the integer value. Thanks for watching this lesson. In the next lesson, we will cover the methods and attributes available on the floating point numbers.